It is not always possible to capture all the required data points for a spool from one location. This can occur when surveying large spools or during in situ surveys where your line of sight is blocked. In this video, we will show you how to move the instrument mid-survey so that you can capture all the data points required and ensure excellent flange coverage. In this case, we're moving the instrument because an obstruction prevents us from being able to observe both flanges on the spool from the same location. Before we start our survey, however, we need to set up control points. Control points enable you to create a reference system that allows you to move the instrument or spool as many times as you like. When moving the instrument, you need a minimum of 4 stable locations surrounding the item being surveyed. Place the large round magnets found in your device set in magnetic locations around your spool and draw a circle around them. Do not put all your control points on a straight line. Try to create an imaginary 3D box around the item you're surveying. Your control points need to provide good scale and shape for your surveyed item. Scale means the size of the control point reference system should be similar or greater than your surveyed item. Shape checks that your control points are not in a straight line. Let's look at 3 ways of capturing control points. Firstly, the start-stop method. Press the control button to start. This informs the system that you want to measure control points. Pick up the lock from your start point and take the prism to the first control point. Then move the prism to the next control point magnet. The computer screen shows the user when the point has been captured. The prism is tracked constantly after the Start Capture button is pressed. When the prism stops moving and is steady, the distance is measured, the angles rechecked, and the observation recorded. There is also an audio beep when the point is captured. The order of capture is not important. The start-stop method should be used when the survey area is small. If the survey area is roughly 10 meters or more, then use the single point method. The next control point capture method is the single point method using a prism. The single point method requires a prism ball for each control point. When control points are far apart or in difficult to access areas, this method is much faster than the start-stop method because the telescope is aligned using the laptop mouse. Once aligned with a prism, press the single measure button and ensure that the prism measurement option is selected. Otherwise, a laser distance will be measured. Any prism ball control points measured incorrectly using the laser option will be invalid. Align the instrument telescope with each control point and capture them in any order. Please contact ML Tech if you require more prisms. The single point laser method is similar to the single point method using prisms. The main difference is that the instrument's laser distance meter is used, rather than the infrared distance meter used to measure prisms. Each survey target must be sighted through the instrument telescope, which means this method takes longer to carry out than the prism ball method. To do this, turn on the laser and point it at your target. Look through the sight and turn this dial until a black cross appears. Then turn this dial until the target is in focus. Then use these dials to make minor adjustments so that the laser is pointing right at the center of the target. This method is slightly less accurate due to human error in sighting the center of control targets. However, it has the advantage of not requiring the use of prism balls. Another significant advantage is that a readily identifiable surface feature can be used on a highly visible but inaccessible surface, such as a ceiling. This control point, for example, can be seen from multiple setups, making it extremely useful in a narrow corridor or other situations where the shape of the control points is an issue. You will always need a minimum of 4 control points. After 4 controls have been captured, the automate system reviews the scale and shape. If acceptable, the control button turns green, indicating that you can stop capturing control points and move the instrument. Capture all the data points you can see from your first position. Then press the Move Instrument button and move the instrument. The capture screen border changes to red and no other buttons are active. Capture at least 4 of the control points you set up in the first instance. After 4 controls have been captured, the screen border turns green. Press the flashing Complete Move button. Now you will see the quality assurance information for the move. We will go through this in detail once we have surveyed our spool. Now you can finish your survey, capturing the spool detail points that you couldn't see from the first setup. So, back at our survey, stand at each setup location and make sure you can see at least 4 of the same control points and the flange detail points. Once you're satisfied this has been set up correctly, you can start your survey. Press the control button and capture the control points using one of the methods identified earlier. When the control point criteria have been met, the control and move buttons will turn green. If the buttons turn yellow, it means the control could be better. A move is possible, but try to reorganize the control points to get the buttons to turn green. The pipe and control must be of similar scale, and the control must have good shape. Now the control has been set up, we can capture all the data points possible from our first setup. Once you're happy you've captured everything possible from this location, press the Move Instrument button. If you press this button and there aren't enough control points in the file, you will be informed and you'll need to take more control points. Now, at the second setup location, make sure you can see at least 4 of the control points and the objects you want to measure. The software border has turned red and most buttons are deactivated. If you didn't want to move and the instrument hasn't moved, you can undo the Move command. The measurement buttons are not yet active. The control must first be measured to ensure that the control point criteria have been met. Again, there must be at least 4 control points. The control must have good shape, scale, and a reasonable fit. We'll measure control points until the Move button turns green or yellow. Again, the order in which control points are captured is not important. When the border turns green or yellow and the Complete Move button flashes, you can proceed. The system will now display the moves report. Overall integrity can be rated as good or fair, with green representing good and yellow representing fair. A scale integrity greater than 1.3 indicates that the control scale is roughly equal to the pipe spool in the design file scale. When shape integrity is yellow, it is greater than 0.2, which corresponds to 1 control point approximately to 100 mm off a 1000 mm long line. Green is above 0.3. The maximum residual in millimeters is the largest error in the fit when the 2 sets of control points are aligned using the least squares method. The movement distance in millimeters indicates how far you have moved between instrument setups. Common points indicate how many control points were used in the fit. All survey points are now in the same coordinate system, allowing you to continue your survey. This is a live registration method that includes real-time fit, scale, and shape checks. Live registration means there is no post-processing of multiple setups, and the flange diameter and PCD checks are updated with all observational data as you take more measurements on a flange common to both setups. The control from both setups has been averaged, and only one list of 4 control points remains from the 2 we captured. There is no practical limit to the number of control points or setups.